All right, second of our calculus rules. The product rule is what we're going to look at today. Now, the product rule is useful when you have two functions multiplied together. At the moment, all we're really looking at is polynomials, so it's a little bit useful. It'll become very useful once we want to multiply, say, a polynomial with a trig function, or a log function, or an exponential function, or something like that. Formally, there's the definition. So u and v are two functions, but again, never used it. Much easier just to think of it this way. Write down the first and diff the second, plus write down the second and diff the first. Again, it has the advantage of you're doing what you're saying, or you're saying what you're doing. Yes, okay, I could expand this out, but let's use it as an example. So what am I saying? Write down the first. Well, the first function is x to the power of 7. Diff the second. Well, the second function's x to the power of 9 minus 6. So if I differentiate that, I get 9x to the power of 8. Plus, write down the second. Okay, x to the power of 9 minus 6. Diff the first. That's 7x to the power of 6. Let's tidy it up. And, oh, actually, we've still got some terms that will collect there. And we get our final answer. As I say, is it really useful for a question like that? Because I ended up having to expand out anyway. So for something like that, it's probably easier just to expand out the initial question and just differentiate that. But, as I say, it was just an example of the rule. So again, yes, probably easier just to expand the whole thing out, but write down the first, x minus 2, diff the second, 2, plus write down the second, 2x minus 3, diff the first, 1. Tidy all that up, collect like terms, 4x minus 7. Just a different way of saying differentiate this product. So this time I go straight to equals because I'm saying the derivative of this is, write down the first, x to the 7 minus x cubed, diff the second, 6x, write down the second, 3x plus 7, diff the first, 7x to the 6 minus 3x squared. A lot of expanding, and yes, there are some terms that we'll collect there, and we get our final answer. Okay, now it starts becoming useful, because we really don't want to expand this whole thing out. That's going to take time. So, and it becomes more fun because we actually apply both of our rules. Write down the first, 3x. Diff the second. Oh, hang on. Anarchy. Bring down the power, lower the power, diff the inside. Oh, now we're getting there. Okay, so 5x squared plus 4 to the power of 4, 2x. Plus, write down the second, diff the first. Now, let's tidy all this up. Yeah, okay, a mere mortal would leave it like that. Let's factor, because that still factorizes. I've got a common factor there of 3. X squared plus 4, always factorize the lowest power. So the power of 4, yeah, and 3, by the way. Yeah, 3, finally. 3 outside x squared plus 4 to the power of 4, 11x squared plus 4. Factorizing it is useful, of course, if I then have to go and find things like where's the tangent horizontal, because I'd want to solve that equals 0, and then that'd be good if it was factorized to do that. Definitely useful for something like this, because we can't expand out 2x minus 1 to the power of a half. So, write down the first, 2x, diff the second, ooh, anarchy. Bring down the power, lower the power, diff the inside. Plus, write down the second, diff the first. So much easier than formulas, isn't it? Okay, so 2x minus 1 to the negative half. Factorise, we have common factor of 2. 2x minus 1, always take out the lower power, so it's negative a half we'll pull out. Left with x plus 2x minus 1, but of course, mere mortal answer. There we go. 3x minus 1 over the square root of 2x minus 1.